Hi, welcome back. So in this part we're going to take a look at some of the steps required to recreate the scene you can see in front of you here in Photoshop. Now the first one, and probably one of the most important, is being able to pose our character. So I'm going to go into Maya and create a very quick rig for character posing. Now if you've been following along with this tutorial, you'll know that we already have a complete rigging solution for this guy. But this is a very complicated rig. It contains HumanIK, contains custom FKIK controls, it contains set-driven keys, it contains dynamics for animating the wires automatically. It contains a whole raft of things that's aimed towards actually animating the character. Now, if you just want to pose the character, this is an awful lot of work to go through to achieve that. So I'm going to show you a method right now to pose a character like this without too much work. So if you've already built the rig that we did in our previous tutorial for this guy, that's great. Use that one. You'll have much more control and flexibility. If you just want to pose the guy, then that's what we're going to do now. So if we look at the composition of our model, you see at the moment he's simply broken up into his different UV patches. So this geometry has been combined, so it's basically one piece of combined geometry for every UV patch for a total of 12 UV patches. So this is the state of our character after we finished our texturing tutorial in Substance and after we finished our UVing tutorial. Now for posing, a quick rig will be fine, and as we've got a humanoid shaped character, I'm going to come in and use HumanIK. So I'm going to make sure that I'm displaying HumanIK. I'm going to set my workspace back to just classic, and I've got HumanIK open here on the side tab. If you don't have this, you can set your modeling, your menu up here from modeling to rigging and go to skeleton, HumanIK, and that will drop the menu in for you. Now the first step is to create a skeleton. So we're just going to do that, and mine has come in to approximately the right scale here. Now we don't want things like controls for fingers. If you want that, you want to follow the much more involved tutorial for creating a rig for animation. As we're just posing this guy, we want to make it as simple as possible. So the first thing we want to do is get rid of all of these finger information joints. We also don't need a base for our toes, so we're going to get rid of that. We're going to come up. Now we've got just about enough hip joints here. Now for animation purposes we might create some roll joints, but for simple posing this will do. And as we look up the body, we've got shoulder joints here that we don't really need for this particular character. So I'm going to set my shoulder clavicle joints to 0. Now we need to delete the right hand side of our rig because this character is mirrored from left to right, so it's identical. So we don't want to be repositioning these joints more than we need to. As I say, this is intended to be a very, very fast, quick rig. So first thing we need is to move these joints into position. Now this arm is going to rotate around this ball joint, so we need to move this into the center of this here. So I'm going to select the joint we want to move. I'm going to select the arm. I'm going to hit Control 1 to isolate that in the view. I'm going to hit the space bar, and I'm going to go ahead and hit Control 1 in each and every other view here. So we're just seeing the parts we need. Now I'm going to select the joint, hit W to move it, and move it into the center. Now if you were creating a rig for animation, you would take more time and trouble about placement and everything else. But as we're just doing a very quick rig for posing, we're going to do this just approximately will be good enough. So that should be everything lined up. It is. And now we can go back to our complete views here and move our next joint into position. So it will be this joint around this bolt. So again, select only the components that you need. So this joint and this bolt, hit Control 1, back into your 4 view, Control 1, Control 1 and Control 1, and this will allow us to place this in the middle of the joint quite simply. So on this one it's a little difficult to see because we have no midpoint on it, but that should pivot around just fine for our intent and purposes. So I'm going to leave it where it is. Now again, Control 1 to bring everything back and look at our final joint. Now our final joint is going to swivel around this guy, so select this guy and the final joint, and the same procedure. So because we've got so few joints here, this is really not, whoops, let me just make sure we have just the joint selected. This is really not going to take us a lot of time. There we go, into the center, F to focus this, get that central, and we are done. So that is basically the arm done. Now I want to move these central spine joints up, but if I do that, I'll move everything else. So there is an easy way to fix this. You select the joint you want, and hit I for, insert key on the keyboard. So I'm going to select the joint I want, hit W to move, hit insert, and that will allow me just to move the joint without moving all the joints down below it. And I'm going to get this guy about in shape to move our head backwards and forwards. So here should be fine. I'm going to hit insert again to make sure I'm just moving the joint. I'm going to bring this one up level with this one. And let's see, what have we got here? So these ones will be fine. This character's not really going to bend at the waist, because if he did, we would need to put some deformations on this. And again, with a quick pose rig, we don't have time for that. This is, as I said, as I have pointed out, simply for posing. So let's come in and get this leg joint done. So we're going to come over here, select the leg joint, and again, Control 1 just to show the portions that we're actually interested in. So F to focus in on here, and the same here, F to focus in, F to focus in. So let's get this somewhat organized. Whoops, make sure we are just selecting our joint here. And we are actually trying for the middle of this piece. So let's come in here, make sure it's about centralized, it's nowhere near, whoops. There we go, that should about do it. So yeah, looking at this, that should pivot in about the right place. We can come back in and change that if we need to. Let's get our next joint organized here, and I'm going to move this to a pivot point that's around the center of this axis here. So that should be fine, and let's do the final one, which will actually be for the foot, which we can't see at the moment. So let's come in and select this, and select our joint, Control 1, Control 1, and Control 1. Again, just so we can make this a little accurate, and that's going to, whoops, let me just make sure I've got only the joint selected, and that's going to make that pivot around the ankle joint, which should be approximately here. Now, as I mentioned, if you were doing a full rig for animation, you would need to be a little more accurate on this. But as we're doing a rig for posing, we can really get away with some sort of slapdash work. So now we need to make sure that we have the other half of our rig in place. So let's select this joint here, and we're going to mirror this over. So if we go up to skeleton here and mirror joints, now I'm going to pop the options open, and you'll see I already have my search for and replace with filled in. Now if we look at the outliner, this is going to be a very common preset for HumanIK, by the way. But if we look at the outliner, window outliner, you can see here that if we look under our character reference, we have got a character spine. It goes to character right arm. So in this case, we would search for character right arm, and when we do the mirror, we would replace that with character arm 1 left. So we're just really replacing the left and right here. So let's just do a mirror across, and now you can see I have a character left arm and a character right arm. So let's do the same with this guy down here. So we're going to come in and just do the same mirroring operation. Now we can just press G on the keyboard to repeat the last command, and that should just about have us done for a very, very basic pose rig. Now we need to come into the definition because it probably won't have seen the left arm yet. So we need to load that in. So if you just click load skeleton definition, the template is HumanIK. We're matching character 1 because that's our source character, and we're hitting OK. And as you can see, everything is in the green. HumanIK understands exactly what's going on. Now, the next step to this is connecting these particular portions to our HumanIK rig. So let's start with the legs. So for the legs, we're going to connect, and this is where it becomes slightly a bit of an issue. It's going to take a little bit of time here. So we want to know what moves when we move this particular bone. Now, at the moment, all this geometry is connected together, so I'm going to go ahead and do a mesh separate. Okay, now I'm going to join all of the pieces that are connected to this bone. So in this case, it would be, let's see, now these are still joined together. So again, mesh separate. These were joined together, as I probably previously mentioned, just to give us a little bit of a helping hand with the UV organization into a multi-tiled, multifaceted UV layout. So again, I'm going to need to separate a lot of this actually. So let's come down and make sure everything is separated. These are probably not. And this is fine, this is fine, this is fine, and these are not separated, so let's separate them. I mean, even this quick rigging is still going to take you, 20 minutes, half an hour, but it's a lot better than trying to fight with the character, trying to select pieces, move the pivot points, and do everything that way. That way would just take way longer in the long run. So this is about as fast as you're going to get a rig for a posable character without too much effort on your part. So that is, for me, these parts as well would move with this bone. So that's what's going to move when this bone moves. Okay, so let's mesh combine this. Okay, done. So that's combined into one object. Now I'm going to bring the outliner back. So outliner here, and I'm going to dock that over here like so, and I'm going to call this one, this would be, according to HumanIK, the right leg. So it looks like the left leg from where we're sitting, but this is the right leg of the character. So let's call this right leg upper. And it is important to keep a naming convention, not only for yourself, but within 3D, you're normally not going to do the whole character yourself. So when you start, or if you're already working in a studio environment, you'll know that it's very common to hand these files off to somebody else. And even if you're never going to do that, if you plan to upload your work to the internet to do a collaboration project with friends, it's quite nice if they don't just have, Poly 2896-B to work with. So once we've done this upper leg, I'm going to delete the history on it, and I'm going to freeze its transformations. So modify freeze transformations. I am then going to middle mouse drag it to the right upper leg portion of the rig here. So you will now see when I select this rig bone, that leg comes with it, and if I articulate this rig, you can see here that that whole bone along with the hierarchy articulates with it. So let's do the lower portion of the leg. So we're going to just combine this again. There really is nothing complicated here. It just can be a tad time consuming. Okay, so is that all the portions we're going to move when we move this leg? Yes, I think it is. So again, mesh combine. And we'll call this one, if we look at right leg upper, this would just be right leg. So let's just call this one right leg. And middle mouse drag that into the right leg. Now, when we move the upper leg here, we'll move the lower right leg as well. And then, of course, we've got another joint here for bending that leg. Okay, so that's nice and simple. Now we've got to attach the foot. So what we'll attach with the foot will be this bolt, and make sure we've got the middle of that bolt selected as well, and this foot. So again, mesh combine. and we'll give that a nice name, right foot. And drag that, of course, into the right foot. So we got right leg here, and underneath that in the hierarchy is, of course, right foot. And now we have a complete set of bones for this leg that give us a fairly easy, if limited, posing ability with this particular character. Now, if you were doing this with a soft surface character, like an organic character where you expected not to have such hard surface bends, you'd need to bind a skin to it. But in our case, we're quite lucky to not have to do that. Now, to get this geometry over to this side, we could mirror it over, but we've already done the UVs and a lot of work on it. So because this is fairly simple, I will just go ahead and combine this like I did the other ones. I'll just do that off screen. So I'll just call it left leg and link it the same way we did this one. I just don't want to bore you guys doing that whole thing again. So if we look at this part here, this is going to obviously be connected to this joint. So if we grab this out of the robot group, and this is right now just called tile 3, so we middle mouse drag it down here, and we'll look for what this joint is called. So this is character right arm, so we'll call this right arm. And excuse my slow typing speed, I've got a studio mic in front of me, so it's quite hard to get to the keyboard right now. But anyway, character right arm, so let's move that into the right arm here, which would be down here. So that goes in the base root of the right arm. Now again, I am going to actually remove these wires. These wires in the full version of the rig are actually dynamically generated. So as you move the character around, the wires would move with it and naturally fall through gravity or wind or whatever dynamic options you've set. But in a simple rig like this, it's going to be way too time consuming to do those just to pose them. If you want them in the final shot, you can easily create a curve and then extrude along that curve to bring the wires back in whatever configuration you want. But for a simple rig like this, it's really not going to be necessary. Now I'm going to need to separate these, so in fact, I needed to separate these as well, because now our right arm is both our right and left arm, which is not a good thing. So what I should have done is gone to mesh separate before I did any of this. And let's see what we've got now. So now we've got a group here called right arm. So I'm going to drag the whole group out like so. And I am going to find just the right arm portion. Then I will drag this out of the group, call it right arm, and drag that into this joint. So again, it's good practice to just delete the history and freeze the transformations on these. So let's see, modify, freeze transformations, and in fact we should make sure that we've done this with everything. So unfortunately think I missed a few of those, but it's really not that difficult because we've got our naming convention. It's really quite easy to find where all our geometry is and just drag it out of the rig. Now we've got that right arm group that will move up there. So as far as I know, there should be no geometry connected to this rig now, and we can check that by selecting one of the parent bones, and there isn't. So here's all the geometry we have got so far to connect, and we're just going to go edit, delete by type, history, modify, freeze transformation. So if you've forgotten that step, you can always go back and correct it. Now let's connect this bone up, which would obviously contain everything here. So once again, a mesh separate. Okay, and make sure you've got all of the pieces that you need for when we combine back together. Okay, so I believe that's it. So let's go mesh combine. Okay, let's find out what the joint will be connecting it to on our character is. So in this case, this will be, let's pop open the group here. And character right forearm. So we'll just call this one right excuse me, microphone in the way again. Right forearm. Okay, and I'm gonna just not do the history and freeze transformations until we've got everything we need laid out here. So all of this stuff here will be, of course, the right hand. So again, making sure we have nice separated geometry on all of these. Okay, that one didn't actually need separating, so that's fine. And for the right hand joint will control all of this. So actually this is probably easier to do a multi-select here. Yep, much easier. Okay, and let's combine this, mesh combine. There we go. And we'll call this one right hand. Okay, so now I've got everything for the right side of the body, realistically. I just need to add a few of these to a few of these joints. So this character is really just going to pivot from the center. So I'm going to actually join these two pieces of geometry together. So mesh combine, and this guy is going to go in the central hip joint. So I'll call it hips and move it to the hips location. In fact, let's not do that until the end. And once we've gone through the hips, so we've got our hips joint here, let's select the joint. Our second joint in will be the first spinal joint, and the first spinal joint we're going to connect this body to. So let's go and find that and pull that out, and we'll call this one spine 01. Okay, so that should do for this. And then the head here is just going to be connected to this. So we need all of this. Now that's going to be fine. And for the head, I'm going to join this one and this one. So I'm going to do a mesh combine. Okay, and that's combined our head. And let's find that geometry. So where is that? We'll call this head. And I'm going to pull this one up. Now the eyes I'm not actually going to combine. Actually in our head should have gone these guys here as well. So let's select those, select the head, do a mesh combine again, and a rename just to head. Okay, so also within the head you would have the eyes, of course, but even with a posing rig we want to be able to make some changes to the eyes. So I'm just going to go mesh, separate, okay, and that will have separated out our eyes. So let's grab everything in the eyes and do a mesh. Let's just do a group, actually. Control G to group this, and let's find the group 1. Let's pull that one down, and we'll call this group eyes. Now we're going to group that together with a head. So group, oops, that wasn't group. Control G to group, and where did that group go? There it is. So we're going to call this head comp for complete, and we're going to move it up. Now what do we have here in this head group? This is simply an empty group node with a transform in it. So we need to delete the history first. So let's select everything, edit, here we go, delete by type, history, and you'll see that empty group just disappeared. Okay, so now we have everything organized and we have everything, his history deleted. Let's just freeze the transformations on everything, and I missed the head there. Okay, now we can start adding it to our rig properly. So this should be fairly simple. Hips 1 is going to go to hips 1. Okay, so that should be fairly self-explanatory. Now right arm we've got here. Okay, that was the right arm group that we mistakenly had joined before, so that one is unnecessary, and we'll call this one left arm. Left arm. Alright, so right arm. Let's put this in the right arm joint. So character right arm, down to right arm, and character right forearm, which would be character... Have I gone blind here? Where is that? Oh yeah, right forearm. Yeah, I have indeed gone blind. There we go. And now we're going to need the character hand, which should be here somewhere. Select the joint. Character right hand. There we go. Character right hand in there. Let's give that a quick test. Yep, that all seems to be working just fine. The pivot points are in approximately the right place. They are at least good enough to allow us to pose the character. Okay, so that should not be doing that. So character right hand, we want that one to go in there, and that one should be in right forearm. Alright, so that's what we were missing. We had one in the wrong place, and that pivots quite nicely. Okay, let me just undo all the changes for this, remembering that we had this right forearm in the wrong node. It's the right forearm is currently pasted under the right arm. We need it under the right forearm. You can see here, right forearm, right arm. Okay, let's do something else. Let's do the left leg. So character left leg, let's throw that in here. Character left leg upper, should I say. Character left leg would just be... in fact, where did we just put that? I think we just put that in the wrong place. Okay, yeah, we did. We put it in the left leg. It should have been in the right leg. No big deal. Let's just put that up to the right leg. Done. And if we expand this out, we'll find character right leg. So we need that to be right leg here. And character right foot. So right foot. This can seem a little confusing at first. So in the right leg, we have right foot needs to go in the right place. Okay, let's give this a little test. This can seem a little confusing the first time you do it. So again, we've got something wrong here. So the character right leg is upper, right upper leg is joined to the right upper leg. The character right leg is joined to this, and the character right foot is joined to the foot. So that should actually work. Yeah, I just made a misselection there of my joint. Okay, so that actually works. So that will do just fine for posing. Now, a couple of other things we've got to put in here are this chest piece. So let's select this joint, which is spine 1, and we're going to go spine 1 to spine 1, of course, and select our character, and that should be everything except the head, which we have here as a group as opposed to just a single piece of geometry, but that's fine. So we're going to find the head joint, which would be this one. Now I'm going to put the whole head on the actual neck joint. There we go. So I should be able to now move this guy up and down. And as you can see, we've got an inner circle here for our head inside. So that will need to come down after we have done an edit, delete by type history. And let's do a freeze transformations as well, and then move that inside the head complete group. And now if we select the neck joint, we should be moving around the head here. And we are indeed. So let's select this joint and bow him out this way. Yeah, he's all moving. Obviously this arm is not moving, it's not connected yet. And we should now be able to grab this hip joint here. Yeah, that one works. We should be able to grab the leg joints. That's not the joint. That's why that's doing that, by the way. I'm selecting the geometry, not the joint. So there we go. Select the joint, and there we go. So I am going to do the exact same thing on the other side. So again, left arm to left arm joint here, and so on and so forth. So I'll be back in a couple of minutes when I've done all that, and we'll take a look at putting some rigging controls on this chap. Just very simple ones. Okay, so I've gone ahead and done that just the same as I did on the other side. Now normally I would mirror these across to make it a little easier, but they're easy enough to do in this instance. And also my UVs would need tweaking then, and in this case, with such a simple use case, It's actually easier just to go ahead and combine these and drop them in. It's really not a time-consuming process. So if we click on the main root bone here to see if we've got everything included in our setup, and we have not. We have missed these two guys here, which should probably be joined with this whole pelvis hips arrangement. So I'm going to go to Mesh, Combine, and I'm going to call this hips, and I'm going to delete the history on it. History, and I'm also going to freeze the transformations, of course, and then just drag it back into hips 1. There we go. So let's now click that, and those are now included, so that's good. And we have just missed these portions here, and these portions here I'm just going to connect with the torso. So same thing, Mesh, Combine. This was my fault, I should have noticed these, but you know, things get missed. Let's go to Edit, Delete by Type History, and Freeze Transformations. If you don't freeze the transformations and delete the history, all sorts of weirdness can happen. Also slow down your rig quite substantially in some cases. So let's bung this guy back on the torso joint, which was in this case spine 1. Spine 1, there we go. And let's see, we can bend him here. Whoops, I didn't select the joint, I selected the geometry. We can bend him here, we can bend him there, we can bend him everywhere. So this should be absolutely fine. As I said, you can see here that that has not deformed properly along with this. In order to do this, we'd need to skin the mesh, we'd need to do a much more complete type of rigging solution. This is generally just for base posing, and if you get yourself in a situation like this, you can always come in and move just the geometry about, delete it. You know, this really is for posing for a scene where the character is not going to move. It's really not for animation. But it's, you know, that being said, you could do a very simple animation with this. I would recommend, however, doing a more complete rig. So now we should have all of our character, no extraneous geometry, everything should be contained here within character reference 1, and that's a good thing. Now I'm going to go ahead and save the scene at this point. Just before I do anything else, I'm going to go to controls. I'm going to go to, as you see, we don't have any, so I'll go to definition, and this button here will create rig controls for us. So if all goes right, you should now see a set of rigging controls that you can grab and move around. And as you'll see, HumanIK does a lot of the work for us. So I can do this, I can go back to a stance position, and now I've got, for what was in the end of the day a few minutes work, you know, you've got a pretty decent rig here, especially for something as simple as character posing. So as you can see, that is, wait, I have just noticed a large error here. Why is that happening? Okay, so let's push this guy this way is fine. Okay, so we've got a little mismatch going on here, I think. Yeah, but it's not that bad. I'm not going to do any extreme poses with this guy, so it should look absolutely fine. What we've done is we've got a joint pivot point in the wrong place, I would say. So we can go back to stance pose. We should be able from here to delete the rig. So if we go up to control rig, none, and we can check out where we have this pivot point located. So I'm going to go control 1, and that looks pretty central. It should probably be set a bit further back, but I'm not going to worry about that unless it affects my final pose. So let's pose this guy. Let's create a rig here. So go to the control rig, and let's say sit him on the floor. So let's put a floor plane in. So plane, there we go. And let's try and sit this guy on the floor with our new rig and see how easy that is to do. Now, as I've mentioned many times, you know, if you are going to animate this guy, then obviously you're going to want something a little more controllable than this. but this for posing does kind of okay. So we put this down here. Now obviously this foot would need to be tilted up a little bit depending on your use case and pose. I can then come in, grab the arms, just move them around a little bit. Whoops. Okay, down here, get him posed in any pose you want really. Now this I'm really not enjoying, so I would probably put a edge loop in here. So let's just go to object mode and let's go to modeling toolkit, multi-cut. I'm going to put an edge loop in here, and then I'm just going to select all of these faces and get rid of them. So make sure we get them all done, and you can make on the fly changes like so. So that was just sticking out a little bit too far for me. So let's move this guy, let's move his shoulder. Of course we need to be on object mode, and let's grab that, and we can move him from the shoulder as well so we don't actually pull the body around. Okay, and let's grab this. And there you go, we've got a relatively quick sitting down pose. Now on this sort of rig you're going to get some errors, but really that doesn't matter because I can actually select the geometry itself and move it about should I need to at a later date. So this type of quick rig is going to get you most of the way there. Let's just do a center pivot on this guy, and then any final little tweaks you want to make after your pose is done, you can, like so. So it is pretty flexible, it is pretty adjustable on the fly like that. And again, we got that situation with this bisecting a little bit, so again we can correct that in terms of the geometry here. This is not supposed to be, as I mentioned, a full animation rig. It's supposed to be for you to get this guy in a variety of different poses quickly and easily. Okay, so I can put him back in his stance pose, and there we go. Now, I hope you found that somewhat useful for posing your characters. If you wanted to do a soft skin character, you'd have to select the whole guy here and the geometry you wanted to make soft skinned, and go and put a skin on it. So skin binds skin. Now I'm not going to get into that. It's a bit more complicated than what we are doing within the confines of this tutorial, which is just posing this guy. If you're interested, especially if you have a subscription so you can go and watch it for free included in your subscription, you can go and watch the parts of the larger rigging tutorial where I actually bind a skin for these sort of soft squishy bits here. So anyway, we'll be back in the next part where we'll be looking at exporting our texture from Substance Painter and adding that to Maya. So I hope to see you for that. I hope this has been somewhat useful. Thank you very much for watching. Okay, welcome back. So now we've got a basic rig in our guy here, so we can pose him within our scene. We need to look at bringing the textures in that we did in the previous tutorial in Substance Painter. So I'm going to pop open Substance, and these are the textures we generated for this guy across 12 UV patches or tiles within Substance Painter. So getting them out is relatively simple. We're just going to go to File, Export Textures up here. Now I'm going to select a preset, so in my case that would be Arnold 5 UDIM for UV tiles, standard, and I'm just going to use this. Now under configuration we've got thickness, position, curvature, ambient occlusion. Let's get on the right set. So we've got base color, metalness, roughness, normal, height, and emission. I'm just going to knock the emission out for now. It will tell me I can't permanently save it, but that's fine. I'm just going to knock it out because within this configuration of textures, we did not actually do any emissive materials, so we don't need them. Now everything else is pretty standard. I'm going to use 8-bit PNGs. The reason for this is there really isn't much point in using 32-bit raw textures within Maya. If you want to color correct these textures and whatnot first, you can of course save them out as an EXR or something of higher quality, color correct them, and then bring them into Maya after you've saved them as 8-bit images. But really, I've done my color correction and grading pretty much within Substance here. So I'm going to select a directory to save these in. Now, in my case, this is going to be under my network scene drive. And I think I called this project, let's see, robot, scene note, robot, something pose and layout. There we go. And I'm going to save this lot under my source images directory, which is the standard directory in Maya for output textures. So I'm going to select that folder. My texture size is set on 4K for all of my patches. So, and everyone is going to output a base color, a metalness, a roughness, a normal, and a height. So this is fine. I'm going to hit export. I don't need the shader parameters in this case, and I'm going to hit export. Now this is going to take a minute or two because it's outputting an awful lot of 4K textures here. So I'm just going to pause and I'll see you back in a second. Okay, so if everything went according to plan for you, you should have now exported a whole raft of PNGs, and you'll basically have one PNG for every attribute and every tile. So in this case, we'll be using 12 UDIMs, 12 UV tiles or patches, and so we have 12 base color textures, we have 12 height textures, we have 12 roughness textures, and so on and so forth. So let's flick back over to Maya and start to look at how we use these. Now, the first thing is we don't want any of the materials on this guy, and also right now I don't want to be seeing this rig. So I'm going to go up to the show and I'm going to untick joints, and then I'm going to untick IK handles, and that way I'll have hidden my rig. I'll be able to quickly select portions of my character without accidentally coming in and selecting a joint or a bone or a control, which is most annoying. So first things first, let's get rid of this floor plane. We don't need it, so I'm just going to hide this. I'm going to select the whole character and I'm going to assign a AI standard material to him. So I'm going to come in, assign new material, and I'm going to go under Arnold, and we're going to go AI standard surface. So this will just automatically create for us a standard Arnold surface, and this might take a minute for some reason. Mine is, there we go. My GPU is not excellent when I'm recording at the same time, so apologies for any slight delays you might see. Now let's go up to Window, and we want to look at the node editor. We are going to graph a portion of this character so we can get to the material, and this should show us the AI standard surface. So we'll click this one, and this shows us the standard surface shading group and the standard surface itself. Now select these two things and hide those from the node view. It doesn't actually delete them, it just hides them from our view, so we've got a little less confusing work area. Okay, so the first thing we're going to want to do here is just bring in a file node. So I'm going to hit tab and type file and file texture. This is a standard Maya file texture node. So within this texture node, I am going to load in the normal map here. I prefer to go with the normal map first so I can make sure it's working. As I probably said, if you go with a color first and everything else, it can be difficult to see the detailing within your normal map. Now, to get this normal map connected, there's a couple of things you need to do. First off, the color space is wrong. For a normal map, you do not want Maya to be correcting the color, so you want to set this to raw for a start. However, I'm going to leave it as sRGB because this is one of the things within Arnold that goes wrong for people a lot of the time and then can be a pain to correct because of the way Arnold generates its TX textures. So bear in mind, if you do this, you can set it straight to raw. It'll be right the first time. I'm going to do it wrong so I can show you how to correct it. Now that's fine for the file node. We're going to be using the alpha channel of this file node, so we need to tick alpha is luminance. Now we're going to bring in a standard Maya bump 2D node, so that's there, and we need to connect these things together. So I'm going to middle mouse drag the file node here into the bump value, and you'll see that's connected the alpha channel here, the alpha, into the bump value, which is the reason we needed to tick alpha is luminance. Now bearing in mind that we currently have this set on the wrong color space, I'm going to now connect this to the AI standard surface. So I'm going to pop it out until I can see its attributes, and I'm going to connect the out normal to the normal camera of the AI standard surface. Now if we look in here, you'll see this has gone hideously wrong, because we've got this logo here created up here, we've got it created on the arms, and that's because we did not tell Maya that this was a UDIM. So tile in mode UDIM, Mari, I believe Mari pioneered this, which is why it's under Mari. However, it is the same for Substance Painter. Now we're going to hit generate preview, which can take a while because we've got 12 patches on this thing, which should generate a preview in our display here. And there we go. Now, one of the things you'll immediately notice is this just does not look right. We've got all this banding here, and this side is white and this side is, not. Now, one of the things to check is under the bump 2D node, Arnold Substance Painter by default is not going to flip out the RNG channel. So we want to turn this flippage off, and you'll see that still hasn't corrected the problem. But if we go down to the file texture and turn it to raw, you'll see that this should correct the problem. There we go. So now we have that done like so. Now this is looking very, very heavily bump mapped. So let me just check this. Because it's looking heavily bump mapped, it's because we have our bump set on bump instead of normals. So we want tangent space normals because we have generated a tangent space normal map, and you can see that whole thing calms down and we get a much better representation of what our bump map should actually look like, or in this case our normal map. Now I'm going to make an error again because this is a question I get asked quite a lot. If you put this onto, let's say, sRGB, let's say you forget and you leave it on its default sRGB settings, and you go ahead and you go up to Arnold render view, and you do a render of this. So I've got the Arnold render view open, it seems like. There we go. So I'm going to do a render of this, and you'll see that actually at the moment we'll get a render of absolutely nothing because we have no lights in the scene, and Arnold does not have a default inbuilt light. So if you give me a second, I'll stop this. Sorry, I overlooked that, but this is the important thing. So Arnold is now converting our PNGs to TX, but it's converting them to TX textures with an sRGB color space. So I'm just going to stop this and throw in a dome light. So Arnold lights dome light, should be sky dome light. There we go. And I'm just going to get a render of this. I'm just going to show you that this is going to go awfully wrong with the color space set wrong. So you can see here that we do have that banding showing in this view. It's almost correct, and in fact you could be forgiven for not noticing that. It's fairly evident on the viewport, but on the render it looks kind of okay. Let me just do this again, and this should show you that we do have some areas here that are just not right. I mean, this should not have a line here. This should not be darker than this. There is something definitely up here. So we know what that is because we've already discussed it. It's the color space that's set wrong. So why did I come in and do it wrong on purpose? Because I'm now going to flick this to raw, and I'm going to render again. And a lot of the time, because Arnold has already created those TX textures and it's marked them in use, when you hit render, sometimes it works and sometimes you'll just get a big error. Arnold down here will say, I cannot convert these textures to the new TX values, and I want to show you how to deal with that if it happens to you. Right, there we go, it happened. So it couldn't convert TX texture to the proper color space. So basically, even though we've told it to use raw here, Arnold is still using these old TX textures it created to get the information from, and because it couldn't reconvert them, the information in these is still wrong. Now if you select these and try and delete them, you might also experience another issue where Maya tells you that these files are in use. So now you can't get rid of them and you're kind of stuck. Well, what you need to do is close down the Arnold render view. You need to go up to Arnold, flush caches, flush the texture caches, then go and, now normally this step's not necessary, but I like to do it anyway, then manually delete the TX textures that Arnold created, go in, set your color space to the right color space, which in our case was raw, which it was set on, but it couldn't make those textures, and then re-render again. So Arnold render view, and you can go up to, where are we? We want to regen this snapshot, so we should, not snapshot, sorry, we should render, refresh, render, and this will now render a new scene, and it will try and convert those textures again. So it should be successful this time, but we'll see in a moment. Now, if you open up the directory you're in, you can see Arnold creating new textures here. So it's created a completely new set of textures with the right color space information, and now I should get no errors, and I should be able to do my render. I don't have any black spots, any dark spots, and I've got everything that I need. So now I know my normal is working correctly. So again, normally you would just set your color space to raw and you wouldn't make that mistake, but I made that mistake on purpose here, specifically to show you how to fix it when it comes up, because it does come up with Arnold in, you know, various different use cases. You might have accidentally set your diffuse color to raw when you didn't need to, or, you know, blah blah blah. Now this bump 2D is kind of fine for what it is, but you can't control the bump depth. Watch, I'll turn the bump depth up to 5, but because it's a tangent space normal, you will see that that has no effect for us whatsoever. Let me take a render just to show you that, and you can see already I'm not going to bother let it rendering all the way in, but yeah, it made no difference. If we click down there, so we get rid of that red error message, just so I can show you that's not coming in again, and we'll try, instead of a standard Maya 2D bump node, let's break the connection to this, and let's break the connection to the normal camera, and we'll come in and we'll use an AI normal map node instead. So if we look at the AI normal mode, we now want the input, so I'm going to drag that out to there, input, and you'll see it just won't do it. So in this case, we're going to use the out color over to the input, so we have to hook that up manually, and that's absolutely fine. And for this, we're going to go down, we're going to pop this out, we're going to look for the out value here. So out value, there it is, sorry, I keep clicking, and we're going to connect that to the normal camera. There we go. Now we have this AI normal map node, which has a strength issued to it. So let's do a render and just make sure that has worked for us. Okay, and you can see that that has worked for us. We can see our general normal map is still functioning just fine with the AI normal hooked up. And in fact, let me turn down the intensity of our sky dome here, so it's not quite so white and blown out. We might get a better look at this. So there we go, and no, that really didn't help us get a better look at the normal, but you can see the normal information is still there. So you can use a Maya bump, or you can use a AI normal map bump, and if we increase the strength of this normal map bump to some quite ridiculous value really, but let's crank it all the way up to say 4 and render again, you should see now those come in a lot darker and our normal map is a lot more pronounced. So you do not have to go back to Substance Painter and do another normal map. So this AI normal can give you a bit more flexibility than the standard Maya 2D bump set to tangent space normals. So I'm going to come in and delete the 2D bump, and we will use the Arnold one set at a strength of 1 for now, and we'll evaluate that a bit later to see if we need to set the strength up. Now the next thing I like to add is a displacement map before we add any color, because I think it's just all a little easier to see on a flat grey that we're actually getting our normal and height maps, or in this case displacement, which Substance Painter's height will become displacement within Maya. It's easier for us to see that's all working correctly. So I'm going to stop that. I'm going to leave this part here, and we're going to come back after this and take a look at adding a displacement map to this for our, really detailing which we can get shadows on and whatnot. Now, if you're creating a character for games, then obviously you probably stick with just the normal, but we're not. We're creating a character for a final shot, so we can go ahead and use displacement. and add a little bit of overhead to both our geometry count and our final render. Alright, so thank you for watching. I hope this has been somewhat enlightening with the different ways to do normal from substance, and I will see you in the next part. Okay, let's take a look at displacement. So we're going to clean up our node edit here just to keep it nice and tidy. I'm going to shut these down so we don't have bits all over the place, because this material is going to get fairly complex. It's going to have a great number of textures on it. So let's try and keep it a bit neat, and I'm going to come in and type file, and again I'm going to use a file texture. Now I generally use just a standard Maya file texture to load the initial textures in. So let's find the displacement. Now that's going to have been exported as height. So let's take that height information and let's put the tile in mode to UDIM straight away this time. Now it's found 12 tiles. Now I'm not going to do a displacement preview in the viewport. It's a little slow. In fact, we might take a look at it just so you know how. So let's connect this up first. So now we've got this guy, which is our displacement, and I do recommend you go in and name these to what they are. So normal, and let's come in and name this one displacement, like so. Just so when we click on them, we can have an idea of what they are. Now, AI standard surface, we'll call this main material. Again, just if we hand the file off, it's nice for people to know what we were doing. So we've got this, and this time it doesn't actually connect to the main material, it connects to the main material's shading group. So I'm going to middle mouse drag this file node into the displacement material, and this will create for me a displacement node. Now, in this case, this should be pretty simple. We're going to have a displacement, we're going to get the displacement scale, we've got the displacement linked to an image, we've got the image, let's just see, we want that definitely set to raw for displacement, and are we using alpha? So I believe we should be. For displacement, yes, we're using our alpha, which means not only do we need to set that to raw, we need to make sure alpha is luminance is checked. So this should be fine for a basic displacement, but again, we're going to run into some issues, probably of the fact that we don't have enough geometry in here. So I'm going to come in, and instead of generating a preview for this one and generating a preview for this one, I can actually do this all at the same time by just going to render here, viewport 2 options, and regen all UV tile previews. So if you've got a whole bunch of them on here, this can be a very handy thing to do. Whoops, let me just put that on there. Okay, so now I've got my displacement linked. Let's get a render and see what that looks like with both my normal map and my displacement on there. So Arnold render view, and this is going to have to generate the TX textures again. So if we look in our directory here, you should see in a minute a bunch of height TX textures being created. So there you see it generating in Arnold, and there we go, a whole bunch of height TX textures have been created, and you can see that something once again has gone a little wrong, because he's now developed well, it looks like an eating disorder, because all of these things are now huge. He's got huge fingers and huge detail here, and he's just got a little bit of weight put on him. And that's because by default, Substance Painter is going to save out a displacement map, especially in 8-bit, where mid-grey is no displacement, black is inwards displacement, and white is outwards displacement. And right now that's not how this is set. So if we go down to our color balance here, where are we? Arnold. And so what do we want here? So actually I think this is under the displacement shader. It is Arnold, and scalar 0 value should be set to minus 0.5. That will make mid-grey the point at which no displacement happens. We also want to turn off auto bump here, because if we have auto bump turned on, Arnold will do any high frequency points of the displacement, so any complicated parts of the displacement. In order to save time, Arnold will do that as a bump map instead of an actual displacement, and we want our displacement. So I'm going to hit play again, and we'll just update the scene, and we will get another render. Now at the moment, every time Arnold renders, it regenerates all these textures. Now we will be turning that off because it takes time when we've got all of our textures on the model. So this is kind of just rendering in right now. Let me just, there we go. And as you can see, this guy is still too big, so I'm actually going to turn that value from not 0.5 but to 0.5, and we shall try this again. Okay, as you can see, it just slimmed right down, and we now have the displacement on our model. Okay, so that adds somewhat to our overall look here. Now, we've got the displacement on, we've got the normal map on, we're kind of seeing our nuts and bolts here. Let me just check everything is correct. It seems to be. Now I'm going to go ahead and exaggerate this displacement. So I'm going to generate a preview for it up here. Now, unless you're using, let me just stop Arnold render, unless you're using viewport displacement preview, which we are not, and you can turn on by hitting Alt F3, I believe. So you select the thing that you want to preview the displacement on and hit Alt F3 and give it a minute, and that should have done me a displacement preview. Now, part of the reason we are probably not seeing that, and part of the reason we're probably not seeing a great deal of displacement here, in fact, if we go into the displacement node and turn up the scale to say 2, now let's just go something outrageous like 4, we should see a lot more displacement happen on the surface of this character, especially around this logo here. So as you can see, that is generating a much higher level of displacement. These rivets have now popped completely out, whereas before they were quite flat against the surface. Now the reason we're not seeing an awful lot of detail in this displacement, I mean the big rivets are okay, but this guy, for instance, is not really popped out. Well, that has to do with the geometry. So if we look at our geometry, it can only displace these polygons, and as you can see, there's just not that much information for it to work with. Now we could smooth this. We could go up to mesh smooth and create an absolutely hugely poly model here, but that has, you know, benefits, well, many drawbacks really. Not to mention the fact that when we come to work on it later, if we need to change it, modeling, sculpting, or, you know, doing anything UVing with a massively high poly surface is going to be a little more difficult. So what we need here is a way to tell Arnold we want to subdivide this at render time, and that's actually quite easy. If you go under the shape node for your particular asset and go down to Arnold, you will see here that we will have a subdivision tab, and at the moment that's set to none. Set it to Cat Clark, and iterations around 3 or 4. The more you go on iterations, the more it will be subdivided. So if you've got a really complicated high frequency displacement, you might need more iterations. I rarely go above 4. Going higher will use more RAM. So if that's a consideration for you, if you've got a system with low system RAM, then you know, maybe that's not the best way to go to crank it above 4. If you've got a ton of RAM and you're doing one single shot, so you've got, you know, an hour or 2 to render it out, that's not going to be a problem for you, then by all means use more iterations if that ends up giving you good quality. So let's look here at our render now, and let's do another render. Now we've given this, just this chest piece, a subdivision iterations of 4. So now you can see, in comparison to what we had before, our displacement now really pops. We've got a really high level of detail on here. So I just close that render window view down for a moment, that render view down, sorry. We're going to look at these iterations again because we had it set to 4, and 4 is actually quite high. Depending on how geometry smoothed or how much geometry you have in the first place, 4 can be awful lot of iterations, and that render at 4 iterations took up around 14 gigs of RAM. So you can see where you could run into problems with higher iterations fairly quickly. So I'm going to do a render with 2 iterations again, so you don't have to, and then we can just do a quick comparison. And I think you'll see when this render is done that it will look pretty much the same as the 4 iteration one in this case. Okay, so here's the difference in iterations. This is 2 iterations here, and this is obviously not high enough res. Now it could do for a distance shot. This is 3 iterations, and this is 4. So you can see we get a slight detail increase with a 4, but actually we just get a slight height increase. I wouldn't say we actually get a detail increase, and this is because our displacement map is currently, I believe, set on a scale of 2. So if we go under and look at this, no, it's set on an outrageously big scale of 4. So generally, you're going to want to leave the iterations around 3, possibly 4. Now, the RAM it's showing usage down here is not what my PC actually spiked to. This took about 2 gigs of RAM extra to render. This took around 4, and this took around 8. So you are getting an exponential increase here every time you go up. For demonstration purposes, I actually put the iterations up to 6, and Arnold basically laughed at the 24 gig of RAM in this machine. It simply wasn't enough. So if you've got some form of dual Xeon workstation with 128 gig in it, this might not be a problem for you. However, you are still going to run into a point of diminishing returns, and it's going to take longer to render, so really don't use it if you don't need it. For me, I am quite happy, especially for previews at an iterations of 3. I just thought I would do this experiment so you could see the base difference here. Now, Arnold's going to render that out in the background when I don't need it to, so I'm just going to hit stop. So basically we've got our displacement map now. Now that scale is going to be probably way too big, so I'm going to go over to displacement and for the moment just set the scale back to 1. I will now do a render of this with 3 iterations on the screen just so you can have a look at it. Okay, and there it is, set back down to a scale of 1 and with 3 iterations. It looks absolutely fine. It looks the way I want it to look. Now, I could possibly increase the scale a tad, but this is more for demonstration purposes. A stamp on metal would not stick out that far. So this is probably going to be fine for me. Something we can come back in and tweak when we get more materials on this beast. Now, to look at this displacement properly, we're going to need some form of lighting in this scene. So I'm going to take my sky dome. I'm actually going to create a floor plane here. I don't know if I had one of those before, but it seems to have disappeared somewhere. So I'm just going to create a quick floor plane, and I'm going to change the sky dome light to a image-based light simply by whacking a HDR image in the color channel. Now I happen to have a HDR image here, and actually it's the one we used in Substance Painter, so it's the HD Panorama. This image can be found within your Substance Painter program files directory. So I'm just going to reuse it here. I obviously won't be distributing it with the tutorial because it's a copyright of Substance Painter. But as this is the one we used to design the original texture, this is the one we're going to use to take a look at all of the textures we bring into Maya. So let's get one more render here, and let's just zoom out a bit so we see the whole thing, and I'll be back when that's rendered. So as you can see, it's rendering in fairly quickly. Okay, so that's not looking too bad. Obviously we're at a very puny resolution right now, and with the displacement, the normal map, it's taken 21 seconds to render, lit by a HDR, so it's pretty quick. But for our intended purpose with quality settings, it's a bit slow. So we're going to rotate this HDR background until the shadow is behind our guy here. So I'm just going to rotate that to bring the light over to about here and do another render and then check out the shadow position on the floor. That's a bit too much. So I'm going to come in. Now normally I would have both of these windows open at once so I can use the IPR in Arnold, the interactive photo render, but with one monitor at a resolution like this, it's a little tricky. So there we go. There's the shadow in the right place for me. And before I go and we call this displacement done, I'm going to get a render in a little more sensible resolution. I would use 4K for the final thing. However, these being test renders, let's see, 1080 should be absolutely fine. Let's get a render of that and I'll be back in a second. Okay, so there we go. We can now see that our displacement plus normal is working together rather nicely at approximately the right scale. Now, close down the render view, and obviously we have some subdivisions on this guy of 3 iterations, but we also have a bit of displacement elsewhere on this model, and we will not have those same subdivisions. So if we go to Cat Clark, and I'm going to use 3 for this, it should be adequate for purpose. It can always be turned up later. You'll see I'm just clicking on the geometry here that would have displacement on it and clicking up to 3 iterations. So come down, make sure you get everything with this. So I'm gonna just select this one, and my copy of Maya here is slowing down a bit because of the recording software. I apologize for that. This is not going to have any big displacement detail on it, so really I'm not too worried about that. And Cat Clark, and just get the bottom here, and Cat Clark and 3, and Cat Clark and 3. Now the first time you do a render with displacement like this, it's probably going to take a bit longer than the second time you do it, because Maya and Arnold are going to calculate all that displacement. So, you know, you'll get a few minutes of delay the first time you go into this, but after that it should be fine. It should render fairly quickly. Now that will change, of course, if you change the subdivisions or you change the render file, the displacement file itself. Okay, let's make sure that's on 3. Just make sure we've got the major areas here. Yeah, we seem to have. Okay, perfect. And I will get one last render just so we can see what difference that made, because our previous render, our nuts and bolts here were a little blurry, and that again has something to do with our resolution and quality settings, which we'll fix later. But for right now, let's just check this guy out in 1080, sorry, and see what he looks like. Okay, so as you can see, with the subdivision iterations applied to the rest of the model, we get a much sharper displacement as expected. Now, you know, this one could do with a little more popping out. Now, you can either increase the displacement scale overall, or you can actually go back into Substance Painter, increase the height of this, and regen your height maps, whichever suits your purpose. But for me, this is a fairly decent displacement map. It's got the details where I wanted the details, so I'm quite happy with the way it turned out. So that deals with the displacement from Substance Painter. I'll see you in the next part when we'll deal with the roughness and things like this. So thank you very much for watching. Okay, welcome back. So now we need to deal with the other textures we generated from within Substance Painter. So we pop open the node editor again. We can once again bring in a file node here, and that's a file texture, of course. And we'll just move the Place 2D texture over here. And we'll go here, and this one we'll load in. I should think the next one to tackle would be the specular roughness. So we're going to get a roughness here, open. Now again, because this is not a diffuse texture, it's not something that's supposed to be seen with the eye, it's more a set of calculations for Maya for where to put the roughness. We're going to use raw and alpha is luminance, because we will be using the alpha value from this texture to connect to the roughness value. So let's make sure we have that set up first. We also need to make sure we tell it it's a Mari UV tile. I'm not going to bother to generate a preview for this. I normally wait until I've set the whole material up and then once again use the global regenerate all previews for everything. So now we've got this, we need to connect it to our standard material here. So we don't want the material shading group, we want the actual standard material. So our main material, Let's move that over there and that this way a bit, just so we're not getting everything all over the place. And we need to come out and we need to take this, making sure we have our settings right. So raw, alpha is luminance, and let's see, we've got it set to Mari UDIM. So we want to take the out alpha from this guy and add him to the specular roughness channel. There we go, like so. And that should pretty much do it. That's going to take a second to update. There we go. And I'm just going to, whoops, there we go. As I said, my graphics card does tend to struggle sometimes when it's doing a recorded video as well. So let's come in, that's connected to roughness. Now let's get a look at what that looks like. So if we look under the material, you'll see roughness is set to 1 and weight is set to 100% because the roughness will control the weight in this case. So we want that at 100%. So let's get a render and see what we're looking like. So let's pop open the Arnold render view, not the Maya one, and hit render here. Right, there we go. So that stopped our chap looking like someone's thrown a bucket of water on him, and we really just got our roughness or specular highlights where we wanted them. So now we can deal with the metallic component of the Substance Painter texture output. So once again, back to the node editor, and that's the wrong window. There we go, and again, a file texture. So file texture, there we are. Let's move that back there so we know what we're dealing with. And I'm going to call this one rather unimaginatively roughness, and this one will be metallic. So again, load in your image, and metallic also will be a raw color space with alpha as luminance. So metalness, there we go, and we're gonna raw, there we are, and tiling mode, of course, UDIM, and alpha is luminance. And now we want to take this metallic alpha, out alpha, there we are, out alpha to the, let's see, there should be a metallic here somewhere. So metalness, there we go, out alpha to metalness. So let's make sure we've hooked that up right. That's just going to do its thing there because I have left the render view on play. So it's currently rendering in the background. Here we go. And now you can see we've got much more specular highlights when we've got that metalness attribute in there. So I'm just going to stop that because I don't think we need to see that complete. You can already see it loading in with more specular highlights to make this a more metallic material. And all we really have left now is, let's just close that down so we're not seeing all those many hundreds of connections in there from the file texture, UV placement. And let's do the last one, which I believe should be just the base color. So file texture again, and bung that back there so we're not looking at it. Color. And this one will be sRGB, no need for alpha is luminance because we'll be using the RG component of the texture. Let's load it in, robot base color, and let's click go. And let's just connect this up to the base color here. So we want out color. Zoom in, yep, we got out color down there. So take the out color to the base color up here. Oops. Didn't connect for some reason. Let's try that again. There we go. And now the out color from our color file is connected to our roughness. Now let me just make sure we have these set to UDIM. We do. This one needs to be set to UDIM also, of course. And now we're going to generate a global preview. So render viewport 2 and regenerate all UV previews. Now this will take several seconds to maybe a minute because it's dealing with 12 patches and 5 separate file textures for those. And there you go, you can see in my Maya viewport a rough approximation of the textures on my model. So just to recap, if you're using AI normal map, you are going to take the out value to the normal camera. If you're using a standard Maya bump map, you are going to take the out color to the normal camera. For the height map, you want to run it through a displacement shader into the shading group, and you want to make sure that you are set to raw and alpha is luminance. For the roughness, you want to plug it into the specular roughness, and again, raw and alpha is luminance. For the metallic, raw alpha is luminance plugged into the metallic, and for the base color, the color should be sRGB. Alpha is luminance, doesn't matter because we're not using the alpha channel in this case, and that should be connected directly to the base color. And we can now get a render of this entire thing with the color on it. Okay, so here we are back with the render. As you can see, all of our maps from Substance Painter are now on our robot. Now, we're not seeing any sort of gorgeous high detail work here for, you know, the bump or the displacement, and we're seeing very basic texture view, and that's mostly to do with the resolution. The textures from Substance Painter, where we generated very large textures so we could do close-ups of this robot, and 1080 is not a very high resolution. So what I'll do with you guys, is snapshot this again so you don't have to, and just show you how much sharper this gets even when it's downscaled on a 1080p monitor like this one, what we get when we render at 4K. So let's stop this and go up to here, and I'm going to set the resolution to I forgot what standard 4K is, just 3840, that's it. I'm going to maintain the aspect ratio 3840, and that should update the height as well. It has, but it's got it a little wrong because that's 2160, not 2161. Okay, so this would be a 4K UHD resolution, and I'm just doing this render so we've got a snapshot of it so you can see the difference that happens in the sharp detail we pick out at a much higher resolution. As I say, even when downscaled to this kind of 1080p monitor. Okay, so our 4K render finished, and if I just flick backwards and forwards here, you can see even downscaled that gives us a much better texture, and it clears up a lot of that fuzziness. So we'll come back in the next part and look at some basics posing, some backing shots, and some other guy to get this, some other stuff to get this guy into an actual scene. So I hope you found something in this part interesting and worthwhile, and I will see you in the next part. Thank you very much for watching. Okay, so welcome back. Now, one of the things I want to take a look at right now is the backing plate, which is why we're in Adobe Lightroom. Now, if you were going to take a more complicated backing plate than this, you would definitely want to get a set of measurements. How far the camera was from the floor, how far the camera was from the main focal point of the object, what the length, breadth and width of the doorway you were shooting were, or if it was a table, indeed the table. However, on this particular occasion, I found myself out and about without all of that other stuff. I just had my basic DSLR camera with me. And there also is that point that there are sometimes some areas where you don't really want to be hanging around with a bunch of expensive camera equipment, you know, with your measuring stick and your notepad. Now, I managed to grab this shot. I was quite happy with it, but as I say, I didn't actually have time to take the measurements. So we're going to have to do this the hard way. Now, one of the most important things for us to ascertain in a backing plate is simply the focal length of the camera when the picture was shot. So in our case, that's 50mm, and that's fine. We can deal with this quite easily. So if we go over to develop, there's a few things we want to do with this. The first one of which is remove any lens distortion. So if we go down to lens correction and click enable profile corrections, and then we find the lens. In my case, it was a cheap Minolta, I think, and I was at about 50mm, so this 50mm profile should about do it. Let's see what that does. Yeah, that removed a lot of the fisheye in the picture for us, and that's about all we need. Now, if you've got a better lens, then you're basically going to have the proper preset for it in here. As I say, I was just using a cheapy lens, so it doesn't have the correct preset, but it's about 50mm, so close enough. Now, there's a whole bunch of stuff we could do to correct this. The first one I'm going to do is a white balance, and I happen to have a white picture in here. So you see my whole image is yellowed up a bit. Now, I don't particularly like that, even though that's probably correct to the daylight settings it was taken in. I'm going to dump the temperature down a little bit because this sort of overall sort of lightish happy color is too happy for me. So I'm going to do this. I'm then going to come down. I'm probably going to drop the exposure a little bit because, you know, our robot is quite dirty and dusty and we want to make this a little darker. I'm going to put a quick contrast S-curve in. So I'm going to come down just a little bit on the blacks and up just a little bit on the whites to make the image pop a bit more. And as I say, you can spend as much or as little time as you want getting your backing plate organized. The important thing for us really is that we know what the lens was shot with, so in this case a 50mm, and we know that that's been corrected so it's not fish-eyed and doesn't have that lens distortion. Now, it would be also a good idea to possibly crop this to a resolution, let's say like one we were using, so 16:9 is what we'll be using for the render. So get that where you want it and then crop it to that 16:9 resolution. Now for me, the above the doorway is a little boring, so I'm going to crop this here, and this can be used now in a 16:9 resolution, which is what we're going to be rendering in. Obviously, if you're going to be rendering in a different not resolution, sorry, different aspect ratio other than 16:9, maybe 16:10 ultra wide or something like this, then you'd need to do that too. So the final step is just to export this image out from Lightroom into Maya. So I'm just going to hit the export here. I'm going to choose a directory. So in my case, that would be really need to clean this up as well. Let's see, robot pose and layout. This will go in the source images. So select this folder. I'm not going to put it in a subfolder. And what else do I need to do? TIFF sRGB is absolutely fine. And rename file to, let's see, file name. Dun. Yeah, that will be fine. No problems there. And just export. Okay, so we're back in Maya, and now we've exported our backing plate, we really need to be able to use it. So to do this, the first thing we need to do is to create a camera to use it with. So we're going to go to cameras, create camera, and you see a little camera has been created down here. Now, if we go to the channel box, there's certain assumptions we can make. Like, I know how tall I am. I'm around 6 feet, so about 183 centimeters, I think that works out at. So my eye level height is probably around 165 centimeters. So the first setting I could set on the camera, don't know why that's set to 400, I'm not that tall, is 165 centimeters. And that brings us almost eye line with a robot who's a little taller than me, I believe. So that would be about right. So we can make an assumption that this shot that I took was filmed or shot at my eye level because I had the camera up to my eye when I took it. Now, other than that, the most important setting that we need to get right is the focal length, because this will change how everything behaves. If I pull the camera back a little bit and then go on to a split panel here by pressing spacebar, we're just going to get rid of, don't know why this is taking so long, excuse me, we're going to get rid of these bottom two, panels, perspective, camera. So now we're looking through this camera. Okay, so if I draw this camera back here and we can say, okay, he looks like he might fit in a doorway now. I was, let's see, 6 meters away with the camera, which seems reasonable from across the street. However, watch what happens when I change the focal length of the camera from 35mm to 50mm. We zoom right in, or at least we appear to, but now we know I was actually a lot further away than 6 meters. I was actually more like 8 or 9 meters away. So the focal length makes a massive amount of difference. Now, so we can do a properly accurate photo match, we want to get rid of complicated things. Like this robot, it's a very complicated thing with, you know, complicated dimensions. So let's get rid of him in favor of something a bit more simple. Now, making sure we're on our camera 1, we want to go to View, Image Plane, Import Image, and we want to import the backing plane that we just shot. So this will import this. Now, this is all the way over here, and we want it all the way over here. So let's look first of all at depth. We just want to make sure that this image plane is behind any geometry we're going to put in front of it, like our robot. So let's come down and look at the depth, and let's just set that depth to 1000. Now you'll see it made no difference whatsoever here. We're just making sure that it doesn't appear in front of any geometry we decide to put in the scene. Now we only have RGB, so let's just go for RGB. There's no alpha on this that we need to worry about. We need to come down here, and the fit is going to be matched to the horizontal and fit to the resolution gate. This shouldn't really be an issue in our case, as we've already cut it to size, but if you're using an oversized image, you're going to need to do this, or what you see on this view will be different to what you render, and that can be horrendously annoying. Now, if I make this a bit wider, there are some assumptions we can make in this scene. We can make the assumption that I was across the street when I took the picture, so maybe anything from 6 to 12 meters away, so that gives us a ballpark. We can make the assumption that because we know my height, that I didn't take the camera while standing on the top of a car, or I didn't balance the camera on the top of my head, so it was probably about 170 meters from the floor, the camera, which is what we've got our camera set to. And we can also make an assumption that this is a fairly large doorway, so something like 2.5 by 3 meters wouldn't be a terrible assumption to make. Now, it would have been better if we'd measured it, but you don't always have that luxury. So let's put in a very simple box to start the matching process. And I'm going to put this somewhere in the middle, tiny box there, and we'll go to its layers and we'll make its height about 2 meters 50. And then we'll move this up here. And yeah, if we was to say this doorway was approximately 2 meters 50, if I actually move the camera in and out, you can see that that then goes in and out. So if I wanted a doorway that was about 2 meters 50, then it would be around here. Now this doorway is obviously a little higher, and that's absolutely fine. So I'm going to make my stick here about 280. Because we don't have exact measurements, some experimentation might need to be done. So doorway of about 280. Now let's see, our stick for some reason is floating up in the air, so let's put that down on the ground. Okay, and we know now that in order to match this thing, we are going to have to zoom out, and we can't zoom out. So we're actually going to cheat and just move the geometry. Now normally you want to match the backing plate to the to the camera. You don't want to be moving the geometry around like this. But in order to make life easier and get this a little more accurate and easy to do, in this case I'm just going to change the point of the floor from down here to up here to make this a little easier on myself. So I'm going to get that and say that's approximately right. I'm then going to widen it out until it covers the doorway. Because this isn't our final geometry, of course. This is just what we're going to use to measure and make sure we're in the right ballpark. I mean, we want to get a render that is, physically accurate, which means we want to get something that's approximately the right size. But is that size, 180 centimeters, 182 centimeters? Well, we don't realistically need to be quite that accurate. We just need to be in the ballpark. We don't want this to be, 4 miles by 2 miles high or anything redonkulous. Now, let's select this camera, and I'm going to come into this camera, and I am going to rotate this camera until our doorway kind of fits in position. So now I'm going to zoom the camera out a little bit. There we go. And you can see we've got the slope kind of right here. I'm going to make this a little smaller. I'm going to push it this way. And the slope is kind of right. These walls weren't straight either. This is a very, very old part of Prague here. So, nothing, the street, nothing is going to be on a very good angle. So we are literally going to have to do some eyeballing around. But we are really just trying to match this up with the angles of our doorway on both the horizontal and the vertical here. So that's obviously not matching the vertical, but I think that's because there's an actual dip in the street, and that of course makes things much more complicated to deal with. In our case, however, that's really not a huge issue because we're not going to be putting like little trash bags on the floor and stuff. We just need to get a basic match. So let's come in, select the camera again, and do a little bit more work here. This can be a little bit tedious. So I think that, let's see, will be about right. And if we look at, just move this down a little bit, if we look at the height of this now, this is now 280 tall, 285 tall and 285 long, which would make that door 2 meters 85 centimeters by 2 meters 85 centimeters, which is about right. It was a very big door. Now if we wanted to make it smaller, we could, make this smaller to the point where we thought it was around, let's say 230 by 230 might be a better size for us. Let's just move that over there a little bit and zoom the camera in. So if we knew the exact measurements of this door, we could just make this box those exact measurements and then zoom the camera in and out until it matched, and then we'd match the backing plate. But as it is, this seems kind of good enough. Now it really doesn't matter where this is, just as long as it matches that backing plate at the right size. So if we look at our camera, according to our camera data, I was standing about 6 meters away when this shot was took, which is probably right. It's probably where I was standing. So let's get our floor plane here to match the bottom of our doorway. So we're saying the bottom of our doorway is at street level. So let me just pull this down and make sure we've got that right. So there we go. It's not perfectly straight, but then again, this whole street was not perfectly straight. I'm just going to take the vertex here and here and shove them a little bit that way. We want to get a bit of better match on that edge and a bit better match on this edge. As I say, this is really not, I live in the center of Prague, so it's very old and nothing was exactly built with what you call a laser tape measure. So let's just bisect that. So the floor will become our floor plane. That will become our doorway. Let's bring our robot back. And 1 and 2 and shift and done. So our robot is actually sticking through the floor right now. So let's make sure we have him all, and let's bring him up to floor level. Okay, so there we are, about there. And I'm going to say that we got the size of our doorway, or we have the size of our robot slightly wrong, because that robot is too big. Now we can, at the moment, zoom the camera out a bit and make the doorway a bit bigger. We can get the robot the size we need it. So you know what though, I'm kind of liking the measurements that we had here. So I'm going to move that back and I'm going to cheat and make the robot a little smaller. So I'd say robot, door's about 2 meters 40, robot's about 1 meter 80, so that seems about right. I'm going to push the robot back a little bit because he would be actually sitting in the doorway there. And one thing I am going to do is I'm going to lock down this camera. Now our camera is matched to the shot. We do not want to be moving it about by accident. So let's just grab everything and hit here, lock selected. And that way I cannot move this about by accident. So now I have the basics of my doorway in place. I need to build these side columns. So it looks like I'm just going to duplicate this to start with. And it looks like we've got a thin side column here. Let's move this over, that comes outwards. So it's got some depth to it. And I'm going to give this quite a bit of depth. Again, measurements, exact measurements would have made this very much easier. So let's look here. That needs to match this, doesn't it? Okay, so that would be like, that should actually be in front. Yeah, let me just turn on off X-ray here so I can get a better look. And this should line up with that about there. Okay, but then that means that our doorway here isn't far enough back. Let me just... Okay, so our doorway needs to be shoved a little bit further back to meet the bottom of the door, and this guy needs to come up round to about here, I would say. Now, again, this is not an exact science with this type of matching, but it doesn't need to be. So Control D to duplicate this. Let's move it out and let's make it a little bigger so it goes off the edge here. And this one is going to jut out a little bit further, so I'm going to make it level with the corner here. So let's turn on off X-ray, and yeah, that looks about right to me, because we've got in the photograph, it could be a little difficult to see, so let's flip open Lightroom, but we've got, you know, a box shape here on the wall between the doorway and the outer frame. So I'm going to make this image bigger. I'm going to go to X-ray, X-ray, and we're going to see what we've got here. So that's kind of matching up with that. That should go there. This should come a little bit more this way, so it's in conjunction with that edge. And then, of course, it should be smaller, because I want it to match this edge here. Okay, and where is the other corner? So that should just about do it. Let me flick out to the 4 view here and just expand this window. Okay, and let's see what that looks like. That looks like it matches the picture just about. So it's a little bit of a pain not being able to zoom this other camera, to be honest. But right now we need to duplicate this and move it along here, so it matches that. And then I'm going to duplicate this and move it along here so it matches that. And then I'm going to duplicate this and move it along here so it matches this. So that's the corner there, and that's the corner there. Again, let's just check it on this view. Okay, this needs to be a little wider and then pushed a little back. As you can see, this is very, very rough matching by eye, but that's really all it needs to be. So is there a gap there? Yeah, there is. Let's make this a little wider and push this out. And how are we doing on our matching? So not too bad. Bottom of the doorway, bottom of the walkway, bottom of the walkway, bottom of the walkway, side, 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 and window over here. And that builds us up a street level that looks a little bit like that. Now, the reason for building all this was not to fully replicate the building behind us, it's to catch shadows. So let's put this guy into a little pose. In fact, I'm going to pose this guy when we come back. I think that's enough for one part. We've matched the camera pretty well. According to our measurements, our doorway is, let's see here, 2 meters 30 wide by 2 meters 40 high, which is about right. It's maybe a little small. And the height on our robot, if you want to know right now, our robot, according to scale, if we open up the 4 view again, whoops, that's not the 4 view, is it? There we go. I'm going to actually measure our robot to see how far out we are with our matching here. So there is our robot from the side view. I'm going to create a measuring tool, distance tool. I'm going to click here and here at the tip of his head. And the distance there is 1 meter 64. So our robot is maybe 20 centimeters shorter than he should be. But I can live with that. It's in the ballpark, and that's what creating a simple shot like this when you don't have exact measurements. It's all about being in the ballpark. So for a whole scene, we are approximately 20 centimeters out. I can live with 20 centimeters out, guys. All right, so I hope to see you in the next part where we'll come back and we'll pose this guy and we'll get the first of our renders. So thank you very much for watching. Okay, welcome back. So now we need to get to posing this guy and, looking at the elements that will weld this two disparate elements, this photographic background with this 3D model we've created in the front. We need to weld those together. Now, before I start rendering proper, there's a couple of things I like to do for the cleanup process for Arnold. Now, the first thing might seem a little weird, but I like to go in to my textures directory and get rid of all of the TX textures that Arnold has generated. So I've simply sorted my files here by type, and I can get rid of the TX textures. So I'm going to go up to Arnold and I'm going to flush all of the Arnold caches. I am then going to delete all of these images that Arnold has created. Now, this is a step I like to take because I've found sometimes Arnold won't generate the images correctly if we look at the render settings, every time we do a render, Arnold is going to generate those textures. So what I want to do is generate a set of clean textures that I know work, and then I want to turn off this auto convert textures to TX. So first of all, we'll get a render and we'll see what our scene currently looks like. Now, we should just have an image of the robot here rendered against this wall. So we'll actually use this as a bit of a test render to check how our shadows are falling on our grey wall here. So I'm going to go up to the Arnold render view and I'm going to do a render. I'm going to make sure I'm not rendering at some outrageous resolution. 720p is fine. All we're trying to do is force Arnold to regen all those TX textures so we know we're working with the right ones. So I'm going to hit render here, and you should start to see in a second all of those TX textures being regenerated, and I think one just popped in. So yeah, you can see Arnold's regenerating all of those TX textures right now. Okay, so I've got a fairly low-res render here of our scene, and I can immediately see a problem with one of our shadows. It's cutting down diagonally here, which is going to look fairly weird, because if we look, this building would not obviously end here, it would extend upwards. So just to get us that shadow in the correct place, I'm going to select all the vertex on top of the wall here and extend the wall upwards so the shadow doesn't go through a cut-off point. Now also we'll notice if we look at our scene, it's generated all of the TX textures that we need. So if we go ahead now and turn off that generation, it should be able to perfectly fine not have to do that every time we go through this process. So if we go ahead and Arnold render and turn off auto convert TX textures and instead use the existing ones, that will be more acceptable to me. I'm also going to turn the tile size down a bit, because when it renders these tiles, it will render basically one on each thread or processor core. So if you've got more cores, you can decrease the size of the tiles, and this will speed up preview rendering somewhat. So let's go ahead here and change these, change our geometry here so it's see-through to the camera. Now we want it to be see-through to the camera, but we still actually want shadows to fall on it. So I'm going to select it all and I'm going to group it together for a start. I'm going to pop open the outliner just so I can keep this scene nice and organized. So I'll call this street geo. Okay, and now I can assign a material to this. So let's assign new material. We're looking for an Arnold material and we're looking for a shadow map. This will allow the geometry to be see-through but still retain the shadow information on it. So let's go to shadow map, and if we look in the shadow map, there's not really a lot we need to change. So the shadow color is black and the shadow opacity. You might need to play around with that sometimes, but the vast majority of times that's just going to stay exactly the same. So we've got our Arnold textures now generated and not generated every time. We've got our see-through geometry, so theoretically I should just be able to hit go here and this will work. But there is going to be one more problem, and that's the image-based lighting we use is actually visible to the camera, and we really don't want it to be visible to the camera, so we're going to have to turn it off here. So we can turn off camera visibility here, and that way it won't interfere with our backing shot, and it will still provide the lighting information that we need. So I'm going to come up and hit render. I'm just going to save the file quickly first. So render we go. Now this might pose a problem. Occasionally this will pose a problem, simply because Arnold sometimes needs to be shut down and restarted. So if you've done this and it's causing you large issues, you might want to shut down Arnold and restart the render view. It's been a problem that's persisted now for a number of versions. It's not terribly difficult to deal with, but it can be a bit of a pain. So I'm seeing our shadows falling on our backing plate here. I'm not getting that cut off now, and our 3D and 2D scenes are fairly well integrated together at this point. I am noticing one big error. This shadow here falls straight down, and there's a step right here. So this shadow would not fall straight down like this. It looks a little faked. If we take a closer look, you would expect the step to have some depth to it. Because of the way our shadow falls, it simply doesn't. All the other shadows, however, look pretty good. If we wanted to be real hardcore about this, we'd model in the pipe work, and we'd also model in this lattice. But for me, because the character's going to be sitting down, I'm probably going to be chopping this out of the final render anyway, and it's a lot of work to go through for something that's going to be left on the cutting room floor, so to speak. So let's come in and let's just check where all of our things stand. So I'm going to put the shading here to wireframe. I'm going to click this tower, and as you can see, our tower is slightly in the wrong place here somehow. It needs to come over to here. Okay, so somehow, somewhere along the line, possibly in the initial fitting, we got that in slightly the wrong place. So I'm going to take, all of these vertex here, and I'm going to move them over until they fit where they should be. So that line is now matching this one. It's perhaps a little uneven at the bottom because, as I probably mentioned, this is a very old street in Prague, so it's really not going to be perfectly straight here. But that's looking pretty close. Now we've got this issue with this step, and that's a fairly simple one to sort out. Oops, we've got gap here. Let's just check for any gaps that might have been created. We've got a gap here, so let's match that gap up, and that's probably caused a gap on the other side. It has. Let's take those vertex and just move it over so it intersects. And little tweaks, especially when you don't have, as I've mentioned, a set of precise measurements, you're going to have to eyeball a bit of this detail, and that can cause you to come back a few times and tweak this a bit. Like here, for instance, these back vertex are a bit far forward on the image, so let's grab both of those, and I'm just going to pull those until it's fairly straight with a doorway there to get a more accurate shadow. Okay, now this box is no longer square. You'll see it's more trapezoidal, and that probably has to do with the fact that when we corrected the image distortion in Lightroom, because my camera was just a cheapy lens I was using, Lightroom didn't have the exact profile for it. So we might be contending here with a little image distortion, which again means we need to change the model a little bit. None of this is particularly difficult, but it can be a little time consuming and cause you to do a number of additional test renders. So let's go in here and model this step in, so our shadow on the left hand side there falls correctly. So let's just start with a box, of course, and I'm not going to bother to be too accurate on this one. As I say, this whole thing is simply for shadow matching. When I've done a test render of this scene, I will also do a render without any geometry in the scene, just so you can see how important that shadow matching is to the scene itself. So let's bring this step down here. Now obviously it's difficult to match right now because it's sticking through the floor, so let's hit the vertex on the bottom. Let's grab all four of those and bring it up. Whoops, I've missed one, of course I have. And bring it up so it's just bisecting with the floor, and we can see the height of it Now in the backing plane here is still a little bit high. Back to object mode, and let's just make sure we're slightly bisecting with that. I'm going to put this down a little bit, and I'm just going to eyeball this in so the step seems to be about that far back. So that's got our step in, that's corrected this wall, we corrected that shadow there. So let's get another quick render. Now on this step we're going to make sure that it has the AI matte material in, the AI shadow matte. There we go. And quick render time. So I'll do a snapshot of this one and then just re-render. Okay, so if you look here at the bottom now, you can see our shadow actually steps up onto this step here, whereas before it just fell right down. So it gives us that extra little bit of believability there. Now what I'd like to do now is, we spent a lot of time, or not a lot of time, but we did spend some time and effort to set up this backing plate to have the shadows fall on it to integrate us with the photograph a little better. So I'm going to snapshot this guy, and just to show you guys what difference that makes, I'm going to now hide all of our geometry here and just do a render without it. So this would be the same as if we just thrown this guy on the backing photo, not bothered to create any geometry for it, and just rendered it out. So let's have a look at that. Really this is just an exercise to show you that modeling accurate backing geometry to match your plate here is fairly essential. So it seems like Arnold is still rendering that geometry in the scene. So what I'm going to do right now is I'm going to close the render view down and I'm going to open it up, which will have the whole scene regenerated. Okay, so here's our original render with our backing plates in, with our backing geometry, and you can see here the shadow on the wall, the shadow up to the step. You can see the shadow of the robot on the wall. There's no specular highlights and stuff over here because of the shadows. You can see a shadow here. So apart from the fact that I believe at the moment we've got the robot bisected slightly through the floor down here, so that's not working very well, but that's just a case of lifting him up a bit. Here's what he looks like if you just dumped him from, say, a render into Photoshop, or if you hadn't built that backing geometry. Now, as you can see, there's no shadows on the wall, there's no shadows here. In fact, this is just wrong in so many ways. It looks like the robot is kind of, here it looks fine, and here this is very obviously fake. So that's why you go through all of the trouble of matching your geometry to your backing plate, because this looks grounded in the scene and this looks, well, frankly ridiculous. It looks like it took somebody a minute to just overlay one image on top of the other, whereas this one gives us a sense of believability. Okay, so I know I said in the previous part we would do some posing in this part, but I'm going to leave that till the next part. Now we've got all our ducks in a row, we can really start to pose this guy in the scene so he looks not only correct in the scene, but also so he has a bit of atmosphere and personality to him, because obviously you don't want a robot standing in a T-pose in the middle of your nice new render. So I'll be back in a moment and I'll take you through the pose that I do for the robot, and possibly some of the final render settings we'll be using. So thank you very much for watching. I know this has been a bit of a job to match these plates together, but really, as you can see, when we flick backwards and forwards between these admittedly fairly low resolution renders, this one looks great, this one looks bizarre. Okay, so that's where all your extra work went and what it did for you. So again, I hope you found this useful. Thanks very much for watching, and I'll see you in the next part. Okay, welcome back. So in this part we're going to look at actually posing this guy to fit him in the scene a little better. Now I'm going to just use this window as we don't need to see the backing plate and everything, and within here I'm going to bring back our joints and our IK handles. In fact, for this we don't really even need to see the joints, so I'm going to just tick the joints off. Now with the HumanIK rig you're going to be using the IK handles obviously to move them about. So if you've never used one of these before, grab a handle and just have a play. Some of them you're not going to be able to move, you're simply going to be able to rotate. Okay, so in order to make this a bit easier, I'm going to bring in my outliner, so window outliner, and I'm going to dock it on the left hand side here. Done. And the reason I'm doing this is when you're doing a character pose, you want to make sure that you're not clicking the geometry. You want to make sure that you're actually clicking the handles here. If you've never done this before, one of the biggest mistakes or worst things you can do is grab a piece of geometry and move that instead of moving the IK handle or FK handle. So I'm going to look at where I want to pose my character, and I want him sitting in the doorway. So the first thing, I'm going to grab the whole character itself, and I'm going to just rotate him round. I need the reference as well, of course. Rotate him round so he's in a position where he'd be sitting with his back to this doorway. Then I'm going to grab some handles here and sit him down. So this is a fairly painless procedure, and this HumanIK rig is fairly nice to work with, really. So that seems to be about right as a basic. He's not on the floor, is he? Let's bung him down there, just so we get the barest intersection. There we go. And I'm going to actually look now. This is a case of just artistic license, really. It's where you want the character to go. It could be standing up, sitting down, laying down. I mean, we give ourselves these options when we create the rig itself. Even a fast, speedy rig like this, that's just for character posing, is enough for us to get a fairly good pose on this guy. I'm actually going to bend him forward ever so slightly at the waist. So let's see if we can just bend him forward a little bit, and now I'm going to nudge him backwards a bit. There we go. I really want him sitting, centrally docked in the doorway, but of course I don't want to bisect him on anything. Now I think I'm quite happy with that. So now we can sort out our legs. So I'm going to grab the knee here and push it this way a bit, and I'm going to pull this leg up a little bit, and then of course change the direction of the foot to match. There we go. And really there's not a lot to say about this process. It's just the pose I want to get my character in. It might be different for you. If we pull that too far, we're going to end up pulling the whole character. This is purely an artistic thing. It's how you want your character to sit and whatnot. Let's grab this handle here, and let's move this arm down, and I want the arm to rest on the leg, pretty much like so. Oh, and I think at the beginning of this tutorial we might have corrected this piece of geometry here on the other arm. Let's go ahead and do it here. We can do that, of course, while it's live on the rig. So modeling toolkit, multi-cut, and I'm just going to put an edge in here, and then I'm going to cut away these extraneous faces that I don't want. So just like so, done. I don't like the fact that that sticks out all the way over there. So I'm going to move this other hand in, and you'll see here I've selected the geometry, not the handle, which would be a bad thing. And let's pull him forward a bit, and I'm just going to get this into place. I want it kind of to rest on the top of his knee here. I'm going to pull this handle down a bit. There we go. So we're kind of resting on the top of the knee. I'm actually going to rotate the shoulder joint itself to bring this arm up a bit, so I can then move it down a bit from here, and that will bring the elbow down a tad as well. Push the elbow in maybe, down. You can see that HumanIK is moving our entire character when we do this, which is absolutely fine. It's kind of what we want, and let's bring this out and have this just resting on the top of the knee. Now this can take some time, of course, and I'm doing it quite quickly just so you guys don't have to sit here and watch me for hours at a time. This foot is a little twisted the wrong way. Let's do this. Now the angle of the head can be changed up here, so let's have him looking slightly dejected and downward. Okay, that's looking okay. And let's finally just move this arm down so it's resting in a more natural position, and let's do the same with this one. Let's move it a little bit like so. Okay, let's go back to our view here, and I'm going to turn on shaded smooth shade. And yeah, he looks like to be in a fairly decent position. Now this is something you can, as I said, spend quite a bit of time tweaking, but let's go here and open the render view and do a quick render. So I'm actually going to just save this file. I'm just going to increment and save before I do this, and hit go, and I'll be back in a moment when that render is done. Okay, there is our render done, and he looks pretty decent sitting there in his little corner. Now, there's a few tweaks I would make. I would change the pose slightly. I'm not happy with this foot. These feet are still bisecting the floor a little bit, so we need to change that. And overall, now the character's looking, sitting down, he seems a little bit small. That's probably because his character has quite long legs. So I'm going to just increase the overall size of the character a bit here, because I believe it will match the plate a bit better. And of course that will now need to be retweaked, because he'll probably be bisecting the doorway now. So I'm going to push him out a little bit, the character as a whole, without using the rig. And I'm also going to bring him a little bit this way, so he's sitting slightly out of the doorway, so he's not leaned right up against it. Okay, so that should be a little bit bigger. Now let's fix the feet here, because they are, I believe, yeah, bisecting the floor just a little bit. So let's come in and fix these feet. Oops, you'll see I grabbed the geometry there, not the actual foot control. So let's grab the actual foot control, bring it up a little bit. There we go. Now it's no longer bisecting the floor. And let's just do the same for this one. Okay, just bring it up a tiny bit. Now we've kind of hit a limitation of our rig, because our pivot points obviously weren't precisely placed here. So our feet actually need moving. The actual geometry, which you normally would never do. You would not do this on a full animation rig. This is just a big no-no. But we don't have a full animation rig. We have a rig just to help us pose the character. So if we want to select bits of geometry and move them about, we're free to do so. I will iterate the point though, that this is not something you would do on a full animation rig. You would go back and correct the rig. You would rework the pivot points until they worked from every angle. However, as our rig is just for posing purposes for a single shot, then it's quicker for us to move the actual geometry, which, as I've said, is not something that you would normally be doing. So to this regard as well, when we first made the character here, and I think my machine is making a lot of noise, so I have left the render view on. So I apologize if you hear some background noise there. When we made the head, we left the eyes separate, so we could actually select them independently from the rig. And this is because our eyes by default are kind of wide open, wide stare, and I don't want that, so I want to be able to change the eyelids here. Now in the full rigging tutorial we did, these eyelids are on custom controls, so you can blink them, wink them, close them, open them, but creating those custom controls is a time consuming process, and it's a little hardcore for just a simple character pose with a hard surface model like this. So in this case we're going to go to modify center pivot, which will just center the pivot on the eye, and I'm going to close up these eyelids a little bit. Now in the controls we made, the custom controls, not only did it close the eyelids, it put them in the right place, which, as you can see, with that pivot just centered, takes a little bit of mucking about. Now I'm going to center the pivot on this one too, so modify center pivot, and that one came up quite nicely. So that should do, and let's just do the same on the other side. So again, this is all a time constraint issue, realistically speaking. If you've got a character you just want to quickly pose, then this would be the way to do it, because you will spend maybe 2 or 3 days, even longer in some circumstances, creating a rig to do that for you. So, you know, it's a time constraint thing. If you've got a couple of days to get your render done and your character posed and everything, then this really quick rig solution is not a bad way to go. If you're going to hand it off to an animator, then of course this would be nowhere near good enough for the job at hand, because you can't expect someone to animate an eyelid blinking by, you know, putting multiple keyframes in for something like this. But for us, for this one simple pose, this is actually not too bad. Okay, he looks pretty good. Let me refer back to my render. And yeah, no, I think he just needed to be a little bigger. So let's see him sitting in the doorway now. Sad robot. Lovely jubbly. And let's hit go. And now you can see the top of his head comes up to our blue paint there. So now he's a bit more of a size. Our feet, how are they doing? They're no longer bisecting the floor. Our eyelids still look a bit starey, not quite so much, so I might come in and just update those a little bit more. Again, this is something that you can spend as much or as little time as you want on, realistically speaking. So let's pull this one down here so it matches up nicely. Whoops. And how are we doing on that? Okay, I'm going to isolate this and I'm going to rejigger its pivot point. No, that would be too much work for just this simple thing. I'm just going to have to put up with moving it backwards and forwards like so, unfortunately. Okay, I'm going for quite an extreme eyelid droop here. I apologize, I know this is not the world's most interesting thing to watch. Okay, that eye looks a little better now. Let's change this one. And the reason we're not doing this at the same time is we want our eyes to feel, you know, different from each other, of course. Whoops, I've really pushed that the wrong way. Okay. Okay, so we have our eyes that look a little different. Again, I'm going to take a render just to see what this is like now. And there we go. Much, much better. Much more character now. The eyes aren't just wide, great, starey jobs. So I'll let this render finish and I'll be back in a moment. Okay, so that finished fairly quickly. We're looking at a very small, low resolution image here, so it's good enough to do a test render with. It takes about 30 seconds to render, so it's kind of perfect, but it's obviously not going to be good enough for a final output shot. So let's just stop this from rendering so I don't kill you all with the background noise as it renders away in the background, and I am fairly happy with this pose. Now, you know, it could do with a bit of tweaking. We could move some of the fingers individually, for instance, and we could do more work, but I think you get the point, and I think it's enough that you can go ahead and pose this guy with this very simple rig in kind of whatever stance or circumstance that you might put him in. So now let's discuss some final render settings, because this is no good. So if we go over to common, I'm going to render in 4K. So we'll want to maintain the aspect ratio for right now, and we'll want 3840 by 2160, not 2161. Okay, so that's 4K UHD resolution, which should be fine. Now, in this case, it depends how you want to do your cropping, because if you want to use this as the full scene, 4K will be fine. If you're actually going to crop the robot out to be a much smaller image, then you might want to up that resolution to 8K. It's really not going to take that long to render. I think on this machine I'm using right now, which is a very, very baseline machine, it doesn't have a Core i9 or a Threadripper or anything in it. It's just a bog standard 4-core FX AMD, so an old processor. And it will render this scene in 8K in about 40 minutes. So realistically speaking, if you want to push the resolution on this for a still shot, feel free. Now I'm going to come in and set the rest of my settings here. So let's go to settings. Now we have our resolution done. Let's check out some of our quality settings. So first off, camera anti-aliasing. Well, I'm going to increase the camera anti-AA to 4, which will increase all of this AA. I'm going to then take a look at my ray depth, and really nothing needs to change here. You know, I'm not passing anything through any transparent material or anything, so all of this should be pretty good. I might increase the specular ray depth to get a slightly better specular highlight, but it's not going to make that much difference, to be honest. I might do another level of both diffuse and specular anti-aliasing, and at this point that would be good enough. Probably speaking, you know, these quality tweaks, you are going to notice them a little bit, but the thing is, if we were rendering a grey image, so just a grey Lambert material, you would notice the grain that comes with having lower render settings in Arnold. Because this image is so busy, and photos naturally have grain anyway, when you're rendering a fully textured scene like this, oftentimes increasing those quality settings, all you're going to do to yourself is massively increase the time it takes to render. So I'm going to go ahead and render this bad boy now at 4K and see what sort of time we are looking at on the render. Okay, so there is our 4K image rendered in 8 minutes and 22 seconds. So really not too bad, especially for a single frame. Definitely something I could live with on a fairly low-end machine like the one I'm using right now. Now, for a lot of you, this will be the final step in the process. I mean, this is pretty well matched in color, you know, and it looks pretty good. However, there is a final step we can take to composite it together. Now, I would normally do this in Nuke. It is possible in Photoshop, but within Photoshop, you're not going to be dealing with 32-bit images very well, and that's what we're going to be saving out of our render here. So if you want to just go ahead and take this guy, maybe in a Photoshop, do some color tweaks and whatnot on the whole image, you know, together, you can just go up to File, Save Multi-Layered EXR. And this will save you a multi-layered EXR file, obviously. Now, you could then just convert that to a JPEG if you wanted to post it online or work on it within Photoshop after converting it to an 8 or 16-bit image. For those of you that want to be able to individually color grade the diffuse contribution, you want to be able to individually color grade the background from the robot itself, because the blackest black parts of this robot do not actually match the blackest parts of this image. So you can get a better shot by splitting it up into its component parts and rendering it out individually. Now, I will show you how to do that in the next part, but for the first thing, for people who are just going to take this into Photoshop, there is a plugin that you might find very useful that will open multi-layered EXR files within Photoshop. So if you go to, I believe it's exr-io.com and just download the plugin for Photoshop, this will allow you to open multi-layered EXRs in Photoshop. It's still not going to fix the limitations of Photoshop 32-bit images, but you will be able to do a basic composite that way. So for you guys, if that's all you need, then you are pretty much done here at this 4K resolution with this 8-minute render. Now, obviously, there are other things you can do. You can get a better pose. You can change the lighting by changing the rotation on the background, image-based lighting, so you could have the shadows coming from the opposite direction. There are plenty of things that you can work on to make this image a little better, and then, of course, take it in at Photoshop after downloading the plugin. Now, I want to do something that's a little more complicated here. So in the next part, we will go through generating a EXR with separate images for the diffuse contribution, the specular highlights, the refractions and reflections in this case. In this case, we'll probably end up just needing diffuse and specular. We might need a few other things, but we'll look at that in the next part. And from there, we'll go into nuke. So if you're interested in doing a more full composite, I'll see you in the next part. If you just want this guy for Photoshop, then you're pretty much done already. Just save the image and have at it in Photoshop. So I hope you found this interesting, and I'll be back in the next part when I show you how to split this image up into component parts, take it into nuke, and composite it to give you a little more control and flexibility over the final image. So thanks very much for watching. See you in the next part. Okay, welcome back. So in the previous part we got a 4K render of our little guy here, and to be honest it looked pretty good. It matched the black backing plate quite well. A lot of this stuff doesn't. The black and white points will be completely out and you'll need to correct them in post. So that's what we're going to do with this. It's good, but it's not the best it can be. And when you just save that picture out and take it into Photoshop, obviously any changes you make to that, you'll be making to the background of the image, i.e. the backing plate, and the foreground of the image, the robot, at the same time. Now, the right way to do this is to make sure that the robot's black and white point match the background's black and white point and vice versa. So when you come to do a final color grade, everything will be starting from a level playing field. Now, the way to do this is to go up to your render settings, and we are going to add some AOVs here. So I'll just delete the ones I had and re-add them. Now, you're going to need for this particular model a diffuse and specular. If you were using subsurface scattering, you would need that. If you were using some sort of refractive surface, the transmission you would need, and so on and so forth. I'm going to keep this simple. So if you look at Arnold's AOVs, which are under the render settings, of course, they're rather like mental ray. If you're used to that, render passes or render passes. So the way Arnold does this is you've got the diffuse, which is actually a mixture or a plus of the diffuse coat, the direct diffuse, and the indirect diffuse. So there's a couple of ways you can do this. You can take these three and add them together yourself in Nuke or whatever your post-processing application you're using, or you can let Arnold do it and just take the diffuse. Now, because I want this to be about color grading and color matching as opposed to how to put together AOVs, I'm going to do it the simple way. But we'll be adding this diffuse to this specular contribution. We'll also take the shadow matte. We probably won't end up using it, but it's handy to have. So we'll be adding the diffuse to the specular. If you want, you can take the 3 diffuse AOVs and the 3 specular AOVs and add them up to give yourself even more control. This technique will work just as well if you do it that way. So we've got our 3 AOVs. Now we want to go ahead and just render that out and then save as multi-layer EXR. Now, I'm not going to do that because I've already done it and we've covered the process of basically you're going to hit the big play button and click File, Save As. The reason I've done it before is actually I've recorded this once before and I forgot I didn't have the microphone turned on. So I've already rendered mine out. The next thing you're going to need to do is get a render of that backing plate on its own. So we're going to hide everything else, just Control H to hide everything else, and then render out just the backing plate, which will look like this. Now, this backing plate will have AOVs in it, but they'll be empty, and it's not really anything to worry about. This backing plate took about a minute to render, and normally it would take less than that. I think because I was recording at the same time, it slowed everything down a little. Now, the reason I'm rendering this backing plate out is so I get an exact match to what I had in Maya. If you wanted to, you could of course go and cut the backing plate in Photoshop. It's really up to you. So from here we're going to go to Nuke to start to match and put back our image together. So we're going to separate it out into component parts, put it back together, and give us control over those component parts. So read in the images you saved. Now I've called mine foreground, which will be the robot, and I've called mine, my other one rather unimaginatively, background. So I've got my background image and what will become my foreground image. Alright, so let's separate the foreground out to start with. So if we look up here, you can see that we have a diffuse layer, which is literally just this guy, we have a specular layer, which is just the specular highlights that are on this, and we have here a shadow matte layer. So we need to add the diffuse and the specular together to get an image back that looks like our robot here. So we're going to use a shuffle node. So click on the read node and hit tab and then just type shuffle. There we go. And this will be a shuffle node from this image, which is a multi-layered EXR, to this shuffle node. So we're going to double click the shuffle node, click the diffuse here in and out is RGB. We don't want to bring the alpha channel on every single shuffle node we shuffle out. So if you had indirect diffuse and direct diffuse here, you would shuffle both of those out. But we only have the diffuse. It's enough for this purpose. So again, click tab, click return to get another shuffle node on, connect it to your multi-layered EXR, and this time shuffle out your specular and set to RGB. Now continue to do this with any layers that you might need. In our case, it's just the two, just the diffuse, there we go, and the specular. So double click there, and there we go, just so we know which is which. Okay, so at the moment we can look at the diffuse by pressing 1 on the keyboard, or we can look at the specular by pressing 1 on the keyboard. We need to put these two things together. So I'm going to hit M on the keyboard, which will just create a merge node, and I'm going to create the diffuse as channel B and the spec as channel A. Now if we look, we will see nothing changed. The spec is merely over the diffuse. So our merge node operation is set to over. As this is a composite, it should be set to plus, and you can see now we have a specular contribution on top of that diffuse layer. So if we look at this now, we could add individual color gradings to the diffuse and the spec channel, which would allow us to then grade or correct the specular highlights independently from the diffuse lighting contribution of the robot. And if we'd gone further and broken that down into direct and indirect diffuse, we'd have, again, even more control. But what we want to do now is get a better match with this backing plate. So let's get to a point where our split up render looks identical to our beauty pass render. So let's add here another merge node. So this one, we're going to connect B to the other merge node. We're going to connect A to the diffuse and the B channel to the background node. And you can see now when I hit 1 on here, this merge node is over because the diffuse layer is going over the background. This merge layer is plus because the spec and the diffuse are being plussed together to create the combined look of specular highlights on top of a diffuse material, and then that's all going out to the viewer. So if we've done our job right, the output from this merge 1 here should be identical to the output from the beauty of the render. And it is. So the difference between this is if you just have this in Photoshop, when you put a correction on it, you're going to correct the background, the robot, and the specular highlights. Doing it this way, we can now correct the spec, the diffuse, and the background completely independently from each other. Now, more importantly in this case, we want to make sure that our black and white values for both our foreground and background match. That way we'll have an accurate, or at least better, color match between the CG elements in the scene and the 2D elements, the photograph in the scene. So the way we do this is we need to find the max luminance pixel of the robot, just the robot on its own. So if we disconnect this, we need to find the minimum and maximum pixel value of the blacks and whites on this image, and then we'll need to find the minimum and maximum pixel value of the black and whites on this image, and then we'll need to bring them together so both images share the same value. So for a start, if we look at this robot on his own, the background is black. As you can see down here, 0, 0, 0, 0, there is no color at all. So if we attempt to find the minimum and maximum value now, the minimum value is going to be jet black. Now, it very well could be anyway, but we will never know because whatever we use to try and read the value will pick up on this black in the background. So to overcome that, first of all, I'm going to set up some project settings within Nuke here. So I'm going to hit S, and I'm going to make sure my file size format is on UHD 4K. Now you'll need to make sure that that is the size of your backing plate and the size of your render, which should be the same size. If you followed me, you'll have a 4K image. If you've rendered smaller or larger, change it to whatever you've rendered to. Right, and let's just close everything down from our properties panel so we've got a bit of room to work. And what we need is some form of constant image in the background here that isn't going to mess with our minimum and maximum values. So that's quite easy in Nuke. Just click Tab and type constant. There we go. And make it 50% grey. So in this case, 0.5. Now we have a nice 50% grey we can throw our robot against, and when we now measure the maximum black pixel, indeed it could be, and it looks like there probably is a maximum black pixel on the robot, but now we'll know for sure what those values are without that black background interfering. So let's go down to this merge node and hit Tab and type curve and open up the curve tool. So by default, this curve tool will be set for average intensity. Now what we want is the max luma data. So if we click the curve tool tab here and go to max luma pixel and click go, that will analyze the image. Make sure you're only analyzing one frame here. If you're not, you can change that to one frame, 1 of 1, and give it a second to do its analysis here, and now its analysis is done. So if we go over to the max luma data, you can see our maximum luminance white value is actually 1.7, so it's actually higher than a value of 1, and our minimum luminance is 000. So it did find a pure black pixel in this image. So really in this case, making the background a constant didn't change too much, but if we hadn't done that, we would never know whether it was finding a maximum black in our robot or it was just finding the maximum black of the background, if that makes sense. Okay, so now we've got curve 1 generated and we know the minimum and maximum pixel luminance for this particular robot. We need to find out the minimum and maximum pixel luminance for the background, which is actually quite easy. Let's just click on the background and hit curve tool. Now, because we're not dealing with pre-multiplied images here or alpha channels, we don't need the constant background. This is just one contiguous image. So I can just come in here, click the curve tool, and get a curve tool and find max luma pixel, go, and 1 to 1, that's fine, go. Okay, if I look under max luma data, I've now got another set of data to work with. So the maximum black in this image is not pure black, and the maximum white is under 1. Whereas if we look at the max luma pixel for our robot, we've got a 32-bit raw image here, so our pixel value can go over 1, which indeed it has done. So we need a way to make all of this data from here and all of this data from here consistent across our image. So to do this, we're going to color grade both the diffuse and spec layers here. We'll actually just copy and paste from one to the other to save ourselves some time. So I'm going to click Tab when I'm clicked on diffuse and type grade, and that will throw us a grade node here. That's grade, not grain. Okay, and now we need to take the values from this curve tool here and add them to this grade node. So we're going to take the minimum value and put it to the black point of the grade node. So close everything down so you don't have a lot of extraneous data. Double click the curve tool and then double click the grade node. So again, minimum is going to go towards the black point. So press Control and drag minimum luminance pixel value up to black point. Now we should probably be looking at the output of this so we can see the changes. Now you won't see any changes there because our minimum was actually black. So in this case, it wouldn't have made that much difference, but it's the correct way to do it, and normally it wouldn't be a jet black. So let's take the maximum to the white point now. So you want the maximum, again, Control drag this to white point, and you should see a bit of a change there. That's made our maximum white point value of 1 now. So now our white point is going to be closer towards our photograph. So let's get our photograph data and add that too. So double click curve 2, turn off curve 1 here so it doesn't get confusing. In fact, where are we? Turn off curve 1. So we're on curve 2 now, and we want to take the minimum value and add it to the grade node's lift. So let's take the minimum value and add it here to the grade node's lift. Now I'm going to control drag this up to lift. There we go. And I'm going to take the maximum value and add it to the gain. Okay, so you can see the difference between turning this on and turning this off. So what that's done, or should have done, is equalized our black and white points between these two images. So if I take my merge B and turn the constant off and put it back to the background, and then we look at this image, you can see here my robot's lights and darks are now more in keeping with this photograph's lights and darks. If I turn this off, he looks a bit bright and he looks not quite the right color. I mean, we've got a better match with our backing plate now. Now, of course, our robot looks a little drab because we need to match our midtones, and he also has got no specular highlights at the moment. So let's copy this grade node and then paste it over here and drag it in the spec, and then hit 1 on the output from this, and this will then have the same grade settings as this, and now we've graded and are viewing the specular highlights as well. So now our shadows and highlights from our foreground image match the shadows and highlights from our background image to a much greater degree. Now that doesn't mean you can't play with this. We're going to need to match the midtones somewhat by eye, because this guy went a little bit too dark in this process. So I can use the multiply to lighten him up a little bit. And I can maybe use the gamma here as well to lighten him up a little bit also. This is going to lighten up his midtones so he's not quite so dark. And if I want to put an excessive specular highlight on him, this one's now a little drab, I can come up here and multiply this to get it a little brighter. And now we have an image that much better matches our backing plate. Now in our case, our original image was quite well matched out of the gate. If I turn these two off, whoops, not this one, sorry. If I turn the grade nodes off, so if I turn this grade off and this grade off, you can see that our original match was pretty close. It's a little bright, the shadows aren't quite dark enough, and you know, it doesn't quite match as well. But actually, it's not too bad. This specular highlight here is too high. It's not too bad. And having the image split up, I mean, the original wasn't too bad. This one is just ever so slightly better. And we got lucky in this case that my photograph matched my render quite well. That's not always the case. And grading like this can greatly aid matching the 3D elements to the 2D elements in the scene. You can, of course, now come in and add color correction to your images. You can change the saturation, the hue, whatever you want. You've got control over the diffuse, control over the specular, and control over the background here. I mean, if we wanted to put in a grade node on the background, we can, of course, do that. And we will just be changing the background image. So doing it this way gets us a better color match, and also we have now better control over our background and foreground images. So I hope this has been somewhat enlightening to you, and doing the max luma pixel data thing to get the blacks and whites for the images to match the shadows and highlights from the foreground to the background can be a bit confusing. But once you've done it a few times, it goes pretty quick, and it does actually get you, in this case, a little difference, but in a lot of cases, a significant difference. And even this difference, this doesn't match the colors and tones of the photo quite as well as this does, and that was the point. So I hope you found this tutorial of some use. If you want to save your picture out from Nuke, if you've never used Nuke, just put tab at the end of your chain, put right here, give it a file name, and hit render, and that will save out your image from Nuke, where you can then upload it or share it or do whatever you want with it. Anyway, I very much hope that this tutorial has given you some insights into rendering out a 3D object and putting it in a 2D backing shot. I hope you found this last little bit interesting if you've never done anything like this before. If you finish this tutorial, by all means post it up on our forum, simplymaya.com. Thank you very much for watching, and I'll see you in the next tutorial, hopefully.